Okay, here are the notes for chapter 7.1. This is page 6. Nothing but examples on this page. So, 16A, we've got the blades of a wind turbine at 116 feet long. Propeller rotates at 15 revolutions per minute. Keep in mind, one revolution just means one time around the circle. So A wants the angular speed of the propeller in radians per minute. And so here is what I'm going to tell you about not overthinking. I know that the propeller rotates at 15 revolutions per minute. I know that I want an answer in radians per minute, so I need to get rid of this revolutions. So my revolutions go in the denominator here. I've got 2 pi radians per revolution. So now I'm going to go ahead and cancel those revolutions, multiply straight across. I get 30 pi radians per minute. That's the unit we were asked for, so we are done. 16B, we want the linear speed in feet per second. We are going to take a look at the formula we have that relates linear speed to the product of the radius and the angular speed. And so we've got a radius of 116 feet. We have got an angular velocity of 30 pi radians per minute. Keep in mind that radians is really a placeholder. That doesn't really matter. We can multiply that out. We get 3,480 pi feet per minute. If we want a number, 10,932.7 feet per minute. Okay, 17A, we've got a car moving at a rate of 28 miles per hour. We've got the diameter of the wheels at 2 1/3 feet. And so here is the first thing I did. I'm not crazy about the 2 1/3, even if I convert it to a decimal. I've got a 0.33 repeating. So I'm going to go ahead and convert this to inches. I know there are 12 inches in a foot, so 24 inches in 2 feet, and 4 inches in a third. So 24 plus 4, I get 28 inches for the diameter of that wheel. Okay, so we're looking for revolutions per minute. So let's start with, let's see if I can give myself as much room as possible here. And start with our 28. Miles per hour. I know I've eventually got to convert it into revolutions per minute. So I'm going to start by getting rid of that hour. Okay. I'm going to get rid of miles. I know that if my diameter is 28 inches, their circumference is 28 pi. And I got 28 pi inches per 1 revolution. So I need to get this into inches so that I can convert it to revolutions. So I've got 1 mile here is 5280 feet. I got 1 foot is 12 inches. So my miles cancel. Feet cancel. Got to get rid of that inches. I got 28 pi inches per 1 revolution. if I take a look at this now, I've got revolutions in the numerator, I've got minutes in the denominator. My answer is going to be in revolutions per minute. And I'm going to bypass my circumference over there. When I multiply the numerators out, divide by everything in the denominator, I get 336.14 revolutions per minute. B wants the angular speed in radians per minute. So I've got 336.14 revolutions per minute. I want to cancel revolutions and end up with radians. Two pi radians is 1 revolution. My revolutions cancel. I'm going to multiply across. I get 2,112 and 0.03. We can let that go. Radians per minute. (18) says the edge of a Ferris wheel turns at an angular velocity of 12.5 radians per minute. What is the angular velocity at a point 10 feet from the center? Keep in mind, radius doesn't matter here. The speed that you roll through an angle is going to be the same whether you're close in or farther out. It may feel different at those different points because of the linear speed, but angular velocity does not depend on radius at all. So the angular velocity is going to be the same for any point on that Ferris wheel. So 19 here is going to look an awful lot like 17. This might be a good place to pause the recording, give this one a shot, and then come back and compare if you'd like. But here's what we've got. We got 55 miles per hour. Again, I want the angular velocity in radians per second. So I need to get rid of hours. I need to eliminate the minutes. So my hours cancel, my minutes cancel. I got 5,280 feet in 1 mile. My miles cancel. I have got, what do we need, 12 inches in 1 foot. Feet cancel. I have got 1 revolution. 28 pi inches, so my inches cancel. So we're going to multiply everything in the numerator, divide by everything in the denominator, and we get approximately 0.04. And that's too small to worry about. So approximately 11 revolutions per second. And that's it. That is the end of the notes.